Hi everybody, in this video we are going to discuss about insert at a given position in a circular linked list using C++. So the input for this algorithm will be the list in which we are going to insert, the position where we are going to insert, and the data which we are going to insert. One exception case that we have to consider is when the position is equal to 1. So if the position is equal to 1, then we can directly call the InsertBeginning function and we can return whatever is returned by the particular InsertBeginning function. Otherwise, what we are going to do is we will be declaring a temporary pointer and make it to point to the first node, and also we will be having a counter initialized to 1. And we have to check whether temp is pointing to the last node. If temp is not pointing to the last node, then we have to check whether your counter has reached position minus 1. Why we are doing this is the basic logic that we are going to use is when you want to insert, you will be making your temporary pointer to be placed on the node which is at position minus 1, and you will be making the changes, right? So you have to check whether your counter has reached the node at position minus 1. If it has reached, then you have to make the changes appropriately. Now we will discuss for the case when position equal to 3, right? So your temp is here and your counter is 1. Check whether your temp is in the last node, no. Then you have to check whether your counter is 1 less than the position. No, position is 3 and your counter is 1. So you have to move the temp to the next node and you have to make your counter to 2. Again, check whether your temp is at the last node, no. Then you check whether your counter is 1 less than the position, yes. Then you have to return immediately, right? You have to, not return, come out of the loop, right? And then what you are going to do is, you are going to make the next part of the new node is equal to the next part of the temp, right? So temp's next part actually contains the address of this node 15. So you will make next part of the new node to point to 15, and you have to make next node of temp equal to new node. So the connection will be made like this. So your new node will become part of the linked list at the given position, right? Now let us check for the condition. One more condition that we will be discussing is when your position is the maximum valid. So what I mean by maximum valid is in this particular linked list you have got totally 5 nodes. So the maximum valid position is 6, okay? And your algorithm should work fine for this case also, right? So let us discuss that case when your temp is at the first thing and your counter is 1, right? Check whether your temp is at the last node, no. Whether your counter is 1 less than the position, no. So you have to move the temp to the next node and increment the counter. If temp is last node, no. And your counter is 1 less than the position, no. So increment the counter and move your temp to the next node. Check your temp is at the last node, no. And your counter is 1 less than the position, no. Increment the counter and make temp to point to the next node. Now once again, whether temp is at the last node, no. Whether your counter is 1 less than the position, no. Right? So move the temp to the next node and your counter also increment. Now you check whether your temp is at the last node, yes. So in this case it will break the loop and come outside, and what the algorithm says is the next part of the new node should contain the address or whatever is in the next part of the temp, right? Actually the next part of the temp contains the address of the first node, so this connection will be automatically established, and you have to make the next part of temp equal to the new node. So this connection will also be made and the node will be properly inserted, right? And the invalid cases, if I give the position as 7, then it is invalid. In that case also, as we discussed, the temporary pointer will be moving till the last node coming out, but before making these changes we will check whether the counter value is 1 less than the position. If it is not 1 less than the position, then we will not make the changes, right? So the validity is ensured by checking whether the counter is having value 1 less than the position. So let us formally write the algorithm. As discussed, the input is going to be list, the data and the position. First step checks whether the position is 1. Then in that case you call the insert beginning and you return. Otherwise you create a new node and using the create node function, and the address will be in new node if new node is null. This is an extreme case where your system do not have a memory to allocate for the new node, right? That is very rare, may not happen at all. If that happens, then you have to return false. Otherwise create a temporary pointer, make it to point to the head, and your counter is equal to 1. And while your temp is not in the last node, we are going to repeat step number 6 and 7 as discussed. In 6, you check if your counter is position minus 1, then you have to break the loop. Otherwise, increment the counter and move temp to the next node. And after coming outside the loop, we are making sure that the position is valid by checking whether counter is equal to position minus 1. If counter is position minus 1, then you have to do the steps 9, 10 and 11. In 9, you are doing next part of the new node equal to next part of the temp, and next part of temp is new node, and you will return true. If none of these cases are satisfied, then you are going to return false. This is the algorithm. Let us implement the algorithm in C++. So it is a class. For circular linked list, we have got a class. So your insert position is inside the class, and we will not pass the list explicitly. As object-oriented programming, list will be coming as an implicit object, right? And in the CPP file, we have to define the insert position function, right? So the first step is if the list is empty, right? If the list is empty, then you should return whatever insert beginning is returning, right? So you will pass only the data to the insert beginning function. Otherwise, what you have to do, you have to create a node, right? So you are starting your things. So let us declare node star new node, and then you want to have a temporary pointer also, right? So you will tell new node is equal to create node, call the create node function, pass the data for that, and yeah, if new node, this is extreme case that will happen if your system do not have any memory to allocate. In that case, new node value will be null. If this happens, then we have to return false. Okay, we have to do this. Otherwise, you will be proceeding with temp equal to the head of the list, and you have to have an integer counter also, int counter, and you initialize the counter equal to 1, right? Initialize the counter equal to 1, and while your temp next not equal to head, right? This is how we will check the last node in the circular linked list. So if your temp next not equal to head, what we are going to do, if you are not in the last node, you have to check whether your counter is equal to position minus 1, right? If counter is equal to position minus 1, then you can break the loop. Otherwise, you have to increment the counter and move your next temp to the next node, right? Temp equal to temp next. You have to move to the next node. Okay, and you will, this is what will be in your while loop. And when you come out, before you make the changes, make sure that your position is valid. How we can make sure is, you have to check whether your counter is equal to position minus 1. If so, then it is valid. In that condition, what we have to do, we have to make the next part of the new node, right? New node next part of the new node is equal to next part of the temp. Okay, we have to make this, and next part of temp is equal to new node, right? These changes we have to make, and that's all. We have done. We are done. So we have to return true here. If this is not the case, then you have to return false. If that case is not satisfied, then you can understand that the position is not valid. In that case, we have to return false. Okay. So I have called insert position also here. Let us first compile the code and check it. So g++ cll.c hyphen c hyphen o cll.o, right? Okay, maybe I made a mistake. C++, it's not C. Yes. Then you compile the application file hyphen c hyphen o cll.a.o, right? Yes. Then you have to link the object files. Okay, done. Now you run the code and check. Okay, once we will write and see what should happen manually and then check the code. So you are inserting end 10, right? 10 is inserted at the end, then 7 is inserted at the end, and 15 is inserted at the end, and then 28 is inserted at the end, and then 19 is inserted at the end. Okay, now I am calling insert position 2. At the second position, I want to insert 25. So your 25 should be here, and your output should be like okay, your output should be, sorry, 1 minute. Yeah, your output should be having values 10, 25, 7, 15, 28, 19. Okay, so it's working fine. So you can, I will be sharing the code in the GitHub. You can take and check by yourself and try it by yourself. Thank you.